In 5C, we are discussing how to represent data using tables and graphs. The first type of table we'll discuss are frequency tables. In a survey given to a class, 23 students responded, and these were the states that they selected and that answered the question where they were from. This frequency table displays that data then. You'll see it has two columns. The left column denotes the state, whereas the right column denotes the frequency of responses. So this tells us that 12 students said that they were from Texas. This first column, this list here, these are categories, and categories are qualitative data. So states, any descriptive data there, those are qualitative. Whereas the right column, the second column, is a frequency number that's numerical, and that is quantitative data. So quantitative data with the N tells you that you are working with numbers. Now we'll talk about relative frequency. This may be with fractions or percentages. So this is the same information given in the last table, but in this chart, this is giving the relative frequency. So relative frequency compares that frequency to the other values. Since there were 23 responses in total, and 4 of the students said that they were from Arkansas, then we compare that the frequency of the students from Arkansas with the total amount. 4 divided by 23, this is your relative frequency, but often it's given as a percentage, so that is where the 17% came from, rounded to the nearest ones place. Now, often charts might be useful as well. So in the question, which state are you from? The chart given here denotes or shows the frequency distribution of, this would just be an initial 18 responses. You'll notice in this chart that half of the students that had responded were from Texas. And you can see the other states are listed here. In this case, they're listed by their order in terms of frequency. So Missouri and Arkansas, and then California, Colorado, and Oklahoma each had 1 response there. So the size of the bar there is proportional to the frequency of that response. Cumulative frequency is when you're adding together frequencies. So we're going to talk about this in your homework as well. You'll see this in your homework. But remember, cumulative frequency, like a cumulative exam, is over all of the material preceding. So whenever you are asked to find cumulative frequency, you want to add the previous numbers before that. Now, something that is different is cumulative relative frequency. You'll recall we just discussed relative frequency. It is often given in the form of percentages or fractions. With cumulative relative frequency, you add the numbers or the percentages before that. So for this particular chart here, this was for survey data, and this was considering the respondent's birth year. And for the total number of responses, so over 2,000 responses here, we have the birth dates that were, so anyone that was born before 1949. You'll see that out of the total responses, 610 of the respondents were born before 1949. 610 divided by 2,277, it gives us 26.79%. You'll see that this is the exact same as the cumulative relative frequency here because this is the first line on the table. For the second row, the birth dates between 1950 and 1969, we had 863 respondents. This number, 863, divided by the total of 2,277 gives us 37.9%. The cumulative relative frequency takes both of those percentages, so 26.79, adds it to 37.90, and that is what we have here for the cumulative frequency. This tells us that the respondents, this percentage, so 64.69% of the respondents are born before or in 1969. The last row here, 804 divided by 2,277, gives us 35.31%. By the time we get to the last row here, if we're using cumulative relative frequency, we should have 100%. If this were cumulative frequency, you simply add the frequencies. So the cumulative frequency, you would add 610 to 863 for the second row, and for the third row you would have 2,277 for the cumulative frequency. Histograms are an effective way of presenting data. When we use histograms for quantitative data, it is important to pay attention to the bin size. So the bin size, you can see on this graph, the bin size is much smaller on the left. I believe on the left we have a bin size of, I think, 2 years, about 2 years there. And then on the right side, we have a bin size that is larger than 20 years. The bin size would be the size of the base of that bar in the histogram. And depending on, as a scientist, what you want to convey with your data, using bin sizes, you should appropriately choose the length of the bin, the length of the base. We've discussed confidence intervals a bit in chapter 5, and I wanted to show you with a bar chart what the intent of the confidence interval, what that meant. And so what you can see from this chart on the right, this chart is depicting the length of male fish versus female fish. So we have a particular type of fish. The scientists collected a sample and measured all of those, and this bar perhaps represents the average length perhaps. From this bar, we can see that we have these error bars, so these error bars towards the top. This tells us that perhaps the average male fish of this particular species that the scientist was measuring, the average was perhaps 10, but this error bar says, well, some were a little bigger and some were a little smaller. The female fish, you can see we have error bars here, and again, we have maybe an average here around 20, but we have error bars that indicate that some of the female fish were greater and some greater in length and some were smaller. The error bars here, because they do not overlap, this is an image that is showing you something that we've already talked about in class. If those intervals don't overlap whatsoever, then we are more confident to say that there is a significant difference in the lengths of the fish based on their sex here. If the intervals overlapped some, so if this interval maybe shared some common values with the one on the right, then we would not be certain. That would be not statistically significant. But in this case, this is significant. There is a significant difference between their means. Bar charts are another great way to display data. The chart on the right, so we have 3 groups here. The group in blue, those values didn't differ very significantly from the gray, but we can see for some reason the orange group, those values did. The important parts to point out in this box chart, so these are given vertically, but this is the same information whether they are rotated horizontally. Your right side or your upper side here is your max. These are called the whiskers, and so this would give us our max value of 20. So for the blue, the data that is highlighted in blue here, the max value is 20. The minimum value would be this lower whisker or the one on the left, the minimum, and in this case it was 5. The bar in the middle is distinguishing the median. So in this case, the median was something like 11. The right bar and the left bar of the rectangle are called our quartiles. So our quartile here is about 16. Our lower quartile, sometimes it's called Q1. So lower quartile is about 6 here. The information in the box, in the rectangular box between the lower and upper quartile, that contains 50% of your information. That is called the interquartile range, sometimes abbreviated IQR. Occasionally at the edges of these box plots, you might have circles beyond the whiskers, and those denote outliers. So these are box plots. The interquartile range, remember that contains 50% of the data. Sometimes this is called your 5-number summary: the minimum, the lower quartile, the median, the upper quartile, and the maximum. Those are called your 5-number summary for any particular data. From the survey you saw before, we asked favorite flavors of pie. And in this pie chart, you can see that the size of the wedge is corresponding to the frequency of responses. So for 18 responses, so about 5 people chose other, 4 people chose pecan, 4 for apple, and then 5 for pumpkin. When we have charts that the independent variable here would be time, so over time, we call these time series charts. So this is a simple chart showing us the popularity of Justin Bieber and BTS over the past couple of years. So you can see BTS is in blue here, and Justin Bieber was in red. This is a time series graph. Sometimes these are very helpful to see trends.